To fuse, a plasma has to reach temperatures 10 times hotter than the core of the sun. Nothing you can touch gets it there. So Hyperion heats its fuel from the inside, with a stack of tools that each do a different job. The first is the simplest. Run a current through the plasma and, like a wire in a toaster, its own resistance heats it. This is ohmic heating. It works beautifully at first, and then it fails because a hot plasma barely resists at all. So we bring in beams. Neutral beam injection fires fast, uncharged atoms straight into the core. They slip past the magnetic field, ionize, and slam their energy into the fuel as they slow down. It is heating and fuel and momentum all at once. Then, we heat with radio waves. Tuned to the frequency at which the ions circle the field, ion cyclotron resonance, the wave dumps its energy precisely into the ions we want hottest. It is heating by resonance, like pushing a swing in time. A second wave at a much higher frequency targets the electrons. Electron cyclotron heating. Its beam is narrow enough to aim, which makes it more than a heater. It is a scalpel we can point at a specific surface inside the plasma. That aiming is what enables current drive. A tokamak needs a large current flowing through the plasma, and you cannot run the old way forever. Non-inductive current drive uses those beams and waves to push the current directly. No solenoid required. Getting the current started, though, still uses the solenoid. Like a transformer, it ramps its field to induce and build the plasma current. For Hyperion, that ramp drives the current up to 9.86 megaamps, the anchor the whole equilibrium hangs on. Once the plasma is hot and carrying current, it has to be fed. You cannot just puff gas at the edge. It never reaches the core. So we fire frozen pellets of fuel deep inside, where they ablate and deposit exactly where the reaction lives. Everything the plasma exhausts has to go somewhere. At the edge sits a thin region called the scrape-off layer, where field lines are open and carry particles and heat out of the core toward the walls. Those field lines funnel everything to one place, the diverter, the machine's exhaust pipe. It takes the full brunt of the heat, and without help, it would be a punishing load on any surface material. The trick is detachment. We deliberately cool the exhaust with gas before it lands, so it radiates its heat over a wide area instead of scorching a single spot. It turns a blowtorch into a warm glow. Right at the surface, the plasma meets solid matter across a razor-thin boundary called the sheath. A voltage drop just microns wide that governs how heat and particles finally cross into the wall. Get the sheath physics right and the whole exhaust holds together. So the heating stack has a shape to it. Ohmic to start, the solenoid to ramp the current to 9.86 megaamps, beams and waves to reach fusion temperature and hold the current, pellets to fuel the core, and a detached diverter to carry the exhaust. All of it is modeled together in open simulation, a conceptual design you can inspect, not yet an operating machine. Heat it, drive it, fuel it, exhaust it. That is how you keep a small sun burning inside a machine 1